Thanks, Coach K.
Thank you.
All right. So here's the thing. So with what we're going over in these sessions, right? I'm trying to sort of like not focus too much on the language to sort of give you a bigger picture of how we attack programming problems and how we solve them. Just a second. So, okay. Give her a second here. So anyway, so in these sessions, we're trying to take a bigger picture than just the language. And so for the language portion, I am only covering just the smallest subset of the language, the tiniest core of the language that we can learn and still be able to write by the end of the sessions some sort of interesting program. So so that's fine. But if you go through that material on W3 Schools, your understanding of Java will grow tremendously, because first of all, you'll get the sort of some of the same material, but from a little bit different angle, which will be good. But also there's just a ton more about Java itself on that site. So, so I really encourage you to go and use that site. Now, I'm guessing that I'm going to ask what our fundamental emotion is right now. And I'm going to give you a few choices, and I think I know what the answer is going to be. So maybe not emotions, but I don't know, something. Anyway, are you mostly confused, or mostly anxious to move forward, or mostly, you know, just bored, or mostly super excited about summer? No, about this class. Are you mostly confused, want to move forward, or just bored? Pranav.
Anxious to move forward.
Alejandra. And don't be swayed
two.
from Pranav. What?
The top two.
The top two. Okay.
I'm confused, but I still want to move on.
Okay. All right. Well, that's good. All right. So it's 6:07. Okay, so here's what I'm going to do. I'm just going to really quick give you an overview of a sample program that I have written, and I'm going to add that to what I want you guys to look at it this week. You guys are, I have asked very little of you during the week, but from here on out, I'm going to ask a lot more. You guys really need to spend, if we're going to get anywhere with this material, you guys are going to have to spend a lot more time just messing around with it and getting stuck on things and figuring things out. All right, okay. So here's what we're going to do. I'm just going to quick run through this program, and it'll be a little bit of review, and hopefully it will clear up some confusion and give you a little bit more ammunition for attacking some problems, and hopefully, and then we'll spend the rest of the class moving forward. All right, I gotta share my screen here. Bring this over here, and share my screen. Screen one. Share it. All right. So now you guys should see my screen, right? This little REPL, right? All right. So this program is an example of 3 different kinds of while loops. I was thinking about it, and I think that there's really like 3 kinds of while loops. There's while loops where we wait for something to happen. There's while loops where we count things up. And there's while loops, really probably one of the main uses of while loops is to deal with lists of things. So we haven't covered lists at all yet, but I'm just gonna sort of give you an overview of it real quick. All right, so waiting for something, counting something up, or going through a list. So waiting for something, so like suppose we have a robot and we want it to turn, right? And so usually the way we do it is we start the wheels in motion and then we wait, right? We wait for it to get to the angle that we're interested in, and then we're done and we move forward. So that's one kind of loop. We're like sitting in a loop waiting for something to happen. So this here, this wait for something method. So I've written 3 methods, one to illustrate each one of these examples, each one of these sort of types of while loops. So the wait for something loop starts out, it prints a message, and then it does it asks the system what the current time in milliseconds is, and then it takes that time, the current time, and adds 5 times 1,000 milliseconds to it. So that's another 5 seconds, in other words. So it takes the current time, then it takes a target time of 5 seconds, and then it just sits in this while loop. And each time through the while loop, it checks, it asks the system, okay, well, now what's the current time? Now what's the current time? Now what's the current time? And as long as it's less than this target time, then it just keeps zipping around the loop over and over again, right? And then finally, when the current time is greater than or equal to target time, finally it falls through and does this last one. Right? So again, that's like if we were turning, right? And in this condition, instead of looking at time, we'd be looking at, hey, we'd be reading the gyro. What's the current angle? What's the current angle? What's the current angle? Finally, it gets to where we want, or probably past it, right? And then we stop the motors, or we do a little bounce back or something, right? All right. So, or what else might we wait for? Another thing that we might wait for here, remember that echo program, right? We ask the user, hey, type something in, and then we spit it back out to the user, right? So, but in the homework version of that, I think, I wanted you to wait for the user to type by, right? And every time through the loop, we would check, did the user type by? Did the user type by, right? And then when they finally do, then we're done, we move on. So it's a similar kind of thing. All right. So that's one use of a while loop. Another use of a while loop is to count something. And this is what we were doing in this week's example program. So this particular, how to raise a number to a power like 2 squared or 3 cubed or something like that? You know what I'm talking about? Just nod your head. Yeah. Alejandra?
No.
No? Okay. So if you take 2 times 2, that's called 2 squared. You can think of it as like a square, right? Right, if we're measuring here's a square and it's got a side of 2, right? Then 2 times 2 is the area of the square, right? So 2 times 2, which we might write that way, is also called 2 squared. Now, 2 times 2 times 2, which is sometimes called 2 cubed, because it's kind of like a cube, right? It's like if we had a cube, right, where each dimension is 2, where it's 2 back, 2 down, 2 across, right? The volume of the cube is equal to the height times the width times the length, whatever. So it's 2 times 2 times 2. So anyway, that's just why it's called 2 cubed. But in any event, so 2, and that's written 2 to the 3rd. So 2 to some power, this is called, so 2 to the 10, 2 to the 12, whatever. This is called raising a root to a power. So, and all it is it's just saying, this power just says how many times we're multiplying this root by itself. So 2 times 2 times 2 times 2 times 2 is equal to 2 to the 5th. Sorry, that's kind of sloppy. 2 to the 5th, because there's 1, 2, 3, 4, 5 2s. Okay?
Mm-hmm.
All right. So this is something that we can do in a loop. So all we do is we say something like, here's what power I want to go to. So I would say I want to do 5. Here's the value that I'm multiplying. And then here's my result. It's going to be 2 to start with. And then while the power, let's say we want to go to the 5th power. So we'll set that power to 1. So while power is less than 5, right, then result gets, result times the value. So each time through the loop, we take the value and multiply it again. So the first time through the loop, we've got 2. This is getting kind of sloppy. Oh, sorry, wrong thing. Okay. All right. Let's just say 2. All right. So this sits in this loop, just multiplying result by 2 every time through the loop, right? But we also have to, this loop, the way that I've written it, will go forever because power never changes, right? We set power to 1 up here, and then we never change it. There's no other place where we ever touch power. So every time through the loop, we have to say power gets power plus 1. And so the first time through the loop, power is initially 1. We change it to 2. So 1 goes to 2. Then it goes to 3, 4, and finally it's 5. And when it becomes, when power becomes 5, then this condition finally becomes false, and we drop out of it. All right. I said this was going to be quick, and I'm taking too long on it. All right. All right, so the third kind of loop is where we have a list of things. And we'll get into lists next week, hopefully. But variables, all the variables that we've looked at so far have one value inside the box, right? Just, it's a string, it's an integer, it's a whatever. It's the number 3, it's the number 2, or it's just some string like your name. All right, but we can also, a lot of times it's useful to have more than one value inside a variable. So all right, this is taking too long. All right, so anyway, so we have this variable, it's got this variable called fruits, and it's got apple, banana, blueberry, peach, tomato, and raspberry. I'm not sure if tomato is really a fruit or not. But anyway, so it's got, I don't know, what is this? 1, 2, 3, 4, 5, 6 fruits inside the array. And then what we do, and this is really, really common, is we just sit through this while loop. And each time through, so we start off with our index being 0. The first element of this array, fruits, if we say fruits of 0, if we say, if we say system dot out print line of fruits of 0, that will print out apple, because apple is the, even though it's the first element of fruits, it's, we use the number 0 to access it. Okay, so so anyway, so we sit in this loop, and we just, and every time through the loop, we have this index, and we look at fruits of index, and then we just keep incrementing by 1. All right, so I'm gonna push it out there. You take a look at it during the week, and hopefully you understand it better than right now. Okay? All right.
Okay.
All right, classes. All right, so here's the programming process, right? We first want to understand the problem, then we have to do analysis and design, and then we implement a solution. So analysis and design is what we're focusing on these days. One technique is to break down problems into smaller problems. Another thing is to organize our code, and another thing is to organize our data. And so I gave you one tool last week for organizing code called methods. And this week we're going to look at another one called classes. All right, so methods, right? Methods are like my blocks. So if you remember doing like a long mission in Mindstorms, right? It would look like this. It'd look like, you know, we'd have a block there, another block, another block, another block, another block, another block, and another block. And then we'd decide, oh, we're going to do 2 missions. And so we'd come over here and we'd do another block and another block and another block and so on, right? And by the time we do a big long mission, we've got just a whole bunch of code that we have no idea, you know, really what it does. Or like, you know, well, where's the part where it turns? Where's the part where it, you know, does mission 1, the first mission, or the second mission, right? So so it's very hard to think about. It's very hard to manage a big, long thing like that. So what we do is we put a bunch of stuff into a my block. We say, oh, these 3 blocks over here, we can just, you know, represent that with one my block, with one block by putting that stuff into a my block. These 3 blocks over here, right? So now our code becomes shorter, right? Instead of like all this stuff, you know, setting motors and stuff. Instead, we've just got like one my block, you know, move forward, one to turn, right? One to start doing the mission, one to start, you know, right? So we've got a lot fewer blocks, and we're able to think about them at a higher level. We don't have to think about gyros and black lines and stuff because it's all taken care of inside the my blocks. So methods in my blocks, they let us think at a higher level. They let us reason about the program. They simplify our lives. All right. Well, so classes are kind of like my blocks on steroids. So classes are used to model real world entities typically. So we said like a method is kind of like a machine. So it's kind of like for example, might be an ATM machine, right? You put in like an ATM machine. You put in like your code, you put in your card, you put in a code, and it spits out some cash, right? Well, so a class is like a more complicated machine. It's like more like a real machine, or it's not even a real machine. It's a real world entity, whatever that means. So if we were going to model an ATM using a class, we would have a lot more information, right? The classes have, and most real world entities, right? They not only have behavior, but they also have something that we'll call state. So like if we wanted to model a person, let's think about a person. Okay, so like what kind of information do we have about a person? Are you still there, Pranav?
Yes.
Okay. You went.
My internet was having some issues.
Oh, okay. So if we wanted to model a person, what kind of information do we have about a person? You know, what might we want to keep track of in a computer about a person?
Their name.
Yeah, definitely their name.
Their gender.
Okay, sure. Gender. What else?
Their age.
Yeah, sure. Right. So stuff like that, right? So we have information about a person. This is called the state. Right? So like over the lifetime of all right, well, I won't get into that. We also have behavior. So what kinds of things might we want a person to do?
What?
Well, so it would depend on our application, but like what kinds of things might we want a person to do? Well, we might want them to do something like say hello, right? Or, you know, or, you know, like make a friend or something like that. So
Make
like,
sure they stay alive.
should they stay alive?
Mhm.
Okay, stay alive. So maybe we give them, maybe we have another class called medicine, right? And maybe in order, whoops, maybe in order to help them stay alive, maybe we give them some medicine. So maybe like that would be a parameter to the stay alive method. All right. So, and so this is a class. So we can model a person, we can model people as a class. Now, suppose that we have this class called person, and it's got state and behavior. So let me put it this way. So a person, or I'm sorry, a class has three things. It has a name. So in this case, person, person. It has state, and we've seen those things, and it has behavior. And you might notice that, like, unlike a method, class does not have a type. And that's because a class is a type. So we've looked at types like integer, right? String, double, Boolean, right? We can actually create our own classes. So person actually becomes a type. We can actually create variables of type person. And the thing is, so a person is kind of like a template. So a person is the class. And then if we had a person named Fred and another person called, you know, like Wilma, I like to use Flintstone characters, another one called Barney, these are what's called an instance of the class, or often called an object. So these guys, so these things are all persons. They all have a name, a gender, and an age, and they all have these three behaviors. They can say hello, they can add a friend, and they can stay alive. Okay, but they all have their own copy of name, gender, and age, right? They can all, so Fred is going to have a different name, gender, and age, right, than Wilma and Barney. Okay, so we sort of like have a class, you know, one class and many objects, many instances of that class. Okay. All right, so let's see how this works in practice. All right, first of all, let's take, so how do we define a class? So we've actually been using a class all along, we just never bothered to look at it. So all Java code has to be inside a class. And in particular, for our purposes, we've always used this class called main. And inside main, there's been one method, also called main, which has these funny parameters. Okay? So And every Java class, every Java program, sorry, has a class called main, and it has a method called main. And this is how the compiler knows where to start your program when it runs. So it's going to start there. But, all right, so suppose we want to have a class called person. So we could put person inside the same file, I think, but you don't want to do that. Pretty much every class should be inside, almost 99% of classes should all be in their own file. So we're going to add another file here, and it's going to have its own, and the name of the file has to be the same as the name of the class. So it has to be person.java. All right. Inside here, we'll define, and you can see all this in our cheat sheet. There. We've got all this stuff about classes on our cheat sheet. Here's the syntax of how you create one. Here's stuff about how you use one. And here's some information about what this funny public thing is all about. All right, so we're gonna create this class called person. My computer comes back. All right. With the bullet. Okay, good. So public person. All right. So no, it's got to say class. Public class person. All right. So now we have a class called person, and we want to give it some state. So we want to have like their name. We want to have their age, and we want to have what was the other thing? Their gender. All right. So maybe we'll store that as a string.
Can't you kind of use that as like a Boolean?
As a what?
I
Oh,
forgot.
Boolean. Yeah, yeah. So yeah, you right. So right, you could have a Boolean, and then you could say something like is female, something like that. And if it was true, it'd be female. If it was false, it'd be male. So yeah, we can do that. All right. Then most classes have what's called a special method. So we could have a method like say hello. All right, we could. Whoops. This could something like system.out.println plus name plus and my age is yeah, these usually we use uppercase letters for the variable, for the instance variables like this. So it should be okay. So this is a normal method like we've seen before. Okay. Okay, sure. All right. Okay. I'll just make this a little wider. Okay. So this is just so this is new, right? This is new for us. This whole class stuff and declaring these variables way out here. Nobody knows what they're doing out there. But, all right. But a class can also have a special method called a constructor. We can call this method whenever we want. The constructor gets called when we create a new instance of a person, when we create a new object. So this one doesn't have a return type, right? Let's, see how, like this one, the say hello one has a return type of void. This one doesn't have a return type because the return type is what it does is it helps create this class. So, all right, and we'll give it like in here. So usually what happens in the constructor is you set sort of an initial state for your object. So in this case, name is just going to be equal to name. We're just going to pass all these things through. Age is equal to age, and is female. Kids is female. Whoops. All right. So now we've created a class. It's got a name. It is its own, I'm sorry, it's got a name called person. It's got some instance variables. And it's got a constructor. And it's got a method that uses some behavior. So how do we use this? So now we have this person class. How do we use it? So over here, we can create a variable called person. So person Fred. And we can set it to a new person. And we have to pass in those values that we just said. So Fred, I don't know, maybe he's 32, and he's a male, so false. Okay. So this creates a new person, and then we can say something like Fred say hello. And if we run this,
What's it supposed to say now that it says false?
I'm sorry?
Like, how,
what's the say?
like, it doesn't know what it means when it says false.
False is the gender parameter. So this is saying that he's male. Or what do you mean?
Like, did you program the part where if it's false, it means he's a male?
Yeah, so this is the constructor, right? This is what we're calling is the constructor with the value of false over here. And so we're assigning, so this value is coming in as false. It gets assigned to this instance variable is female. This female is now false. So if we change, we never actually use that value. So we can say something like this. F is female. System of the female. What would I do here to print? What would I do to print out the other side of it? That it's a guy.
Else?
Mm-hmm. Yep. Good. Does this answer your question? I'm not sure that I understood it.
Yeah.
Okay. So if we run this, it will Okay. All right, so suppose we wanted to also have like, you know, Wilma. So what would we do here? How would we create it? So we have one instance, we have one object of person called Fred. How would we make two objects? So we have one that's Fred and one that's Wilma. Or who's your favorite Flintstones character?
I don't watch the Flintstones.
I forgot the names. I watched it when I was little.
All right. All right. Well, anyway, so if we want to have a second person, pick a name.
Luna.
What?
Luna.
All right. So how would we do this? How would we create a second person?
Just type in person and then the name.
Right. I'm sorry, I didn't get the spelling on that name, Alejandra.
Luna.
Oh, all right. Okay, good. So, and then we say a new person and give their name. And I don't know what age we want to say. Let's say 25. And we'll say true, because I believe this is a female. Is that true?
Mm-hmm.
Okay, great. And so now we could just like we had Fred say hello, we can also have Luna say hello. All right. So we have this class called person, and we have two copies of it, right? We have one that's Fred, one that's Luna. If we changed Fred's name down here, if we said, because we can not only access, so because, yeah, okay. So because these things are, but by default, they're public. We said public, whoops. And so we can actually access these variables directly too. Geez. I was trying to type, whatever you probably pronounced that. All right. So we can actually change Fred's name by going over here and say Fred.name equals Fred Flintstone. And now if we said to say hello again, it would, you know, it would be with an updated name. So throughout the course of the program, we can be manipulating these. If I change something about Fred, it doesn't affect Luna. If I change something about Luna, it doesn't affect Fred. Okay, it's just like having two different integers or two different booleans or two different anything else or two different any other variables. Right, it's a chunk of memory that's, you know, separate, but has a commonness about, just like integers have a certain commonness, right? All integers are whole numbers. All integers, you can add them and subtract them, multiply them, right? You can't add, subtract, and multiply Fred and Luna, right? But you can always, you know, whatever behaviors we've given them with these methods, we can do that to any person. If we had another class like medicine, we wouldn't, you know, unless we wrote a say hello method on medicine, we wouldn't be able to say, you know, say hello to it. It would have other behavior to it. All right. Question? All right. So let's suppose we wanted to add a friend. What do you think? How would we? So we want to have a method where we can add a friend. So let me give you this. All right. So in order to be able to add a friend, we can pass a person as a parameter, just like an integer or anything else. So we can say person, or let's not add friend, let's say set friend. Person, new friend. Right. And now we have to be able to set this over here. So we have to, this is a new bit of information that we didn't have about a person before, right? We have their name, we have their age, and we have their gender, but we don't have, you know, who they're friends with. So in order to now record who their friend is, we have to add another variable. I'm gonna have to say public, and this variable is a person. So say that. So initially, there is no friend. So if friend not equal null, system is the plus okay. So oh no, I see. Okay. All right. So now we can have one of these persons become friends with the other, or both of them become friends with whoever they is with another person. Right. So let's run this. Make sure I haven't broken anything. All right. So everything is still working. You notice that it's not printing out any information about friends, right? Because we only are going to print out who my friend is if I have one. So initially, with objects like this, so initial value of is female is probably false. The initial value of age is probably 0 if we don't set it. And but strings and objects like person, if we don't set anything, it's a value called null. It just means that there's no value. Okay. So in order to set it to a real value, what would we have to do? How could we make like Fred be a friend of Luna or vice versa? So suppose we want to make Fred a friend of Luna. So what we need to do is well, we need to call the set friend method, right? That's how we set this variable, right? Okay. So let's go over here. So we have Luna and we have Fred. And Luna's name is Luna. Her age is whatever it was, and her is female, is true. And her friend right now is null. Fred has a name, which is Fred, and he's got an age, and he's got his female false. and he's got friend also null. All right, so if we want to make Fred Luna's friend, we have to replace this, right, with Fred, right, not with the name Fred, but with a copy of this, with this object, Fred. Does that make sense?
Yes.
So, all right. So set friend, so we have this method called set friend, and it takes as a parameter a person called new friend. And in there it says friend, right? Friend equals new friend. So, right. So what this method does, what the set friend method does is it takes this new friend here, right, and assigns it into the friend variable, instance variable. So, okay. So what we do is we say Luna set friend Fred, just like that. And if we run that, and then if we say something, have Luna say hello, she'll tell us who her friend is. Okay, so and you see over here that my name is Luna and she's female and my friend is Fred Flintstone. So now, is Fred Luna's friend according to our code?
No.
Right, because his friend instance variable is still null. He still doesn't have any friends. So you could change that to like do both of them at the same time or something like that. But suppose we did want to do that. Suppose we wanted to make them both. So let's do this. Let's just do Fred say hello. And we'll show you that he doesn't. So Fred still doesn't have any friends. And let's put a blank line between each time. All right. So suppose we want, when we assign somebody to be a friend, that they both become friends of each other. How? Well, yeah. How could we do that? Like, what could we add here that would make the new friend a friend of the friend? So here, right here, Luna, when Luna prints this stuff out, right? When we see these lines here, Luna is one that's executing this code, right? And she says, my friend is named, and then she actually sort of reaches into that object and uses the information on that object. So like here, she's using her own information, right? Her own name, her own age, her own gender, right? And her own friend, right? But here with this dot syntax, she's using Fred's name, right? And so similarly, we could do a similar thing over here. We could say, it's like this is setting our friend to the new friend. We can also set new friend's friend to us. And there's a keyword called this, which means this object, which you didn't know about and which I didn't remember you were going to need until just now. All right. So, all right. So there is, all right, so let's run this now. And now they will become friends with each other. So now they're friends with each other. All right, so before I wrap up, any questions? I know you guys are just like confused as heck right now, right?
Yes.
A little bit.
Yeah. Okay. So here is what I want you to do. First of all, I want you to go to W3 Schools and work through some of that stuff there. And they have a section on classes. I gave you a link. I'll give it to you again. But they have a section on classes. And going through it again, it's going to give you a little bit of a different angle. And you're going to be able to play with it and mess around with it a little bit. And you're going to understand it way better than what you do right now. And if you have any questions, if you're still confused, again, just send me a message and I'll definitely, get back to you. I do respond. I see the notifications a lot faster from WhatsApp than I do from the classroom. So that's the best way to communicate with me. You can send me a private message there too if you want not to bother other people. So that's the first thing. I want you to go into W3 Schools and do that. And then I'm going to give you a couple other
Welcome to Innovate.
homework time. Okay. I'm going to give you a couple of other things to do too. So okay, yeah, right. So, and maybe we can do this in the next couple minutes too. So one homework exercise is to think of a program that you would enjoy building, right? Whatever it is, a video game, a robot control program, pen pal application, something to keep track of, I don't know, whatever. Any program that you can think of, and it doesn't have to be, it could be on a phone, or it could be on a website, whatever. Anyway, some program you would enjoy building and thinking about, and just list some of the real world entities you think this program would have to model. So if I'm writing a program about banks, or, I'm going to have like accounts and customers and what are the attributes on those things? So accounts are going to have like, balances and account numbers and so on. So real quick, what's a program you might enjoy thinking about, Pranav? Or Alejandra, if you have one in mind, you can jump in.
Do you know those types of text-based games where you have to type some and then something, and then you have to read some to see what did you do and stuff like that?
Yeah, right. Like a venture game. Yeah, right.
Yeah.
Okay. Yeah. All right. So let's think about, what we're talking about, Pranav, a venture game.
Yeah.
Okay, so like what are some entities that you would have in that game?
Maybe like items, enemies, and stuff like that.
Sure, right. Like the goblets and the poisons and whatever the gold that you find, stuff like that, right? And the
Mm-hmm.
and the enemies you come across, sure. And the buildings that I don't know if there's probably some landscape, you know, there's like you can go north here, you can't go.
NPCs.
What?
NPCs.
I don't know what's that? Sorry.
I kind of like the characters in a game that are programmed in. So like the townspeople and stuff like
Oh,
that.
I see. Uh-huh. I got it. Yeah. Yes, right, exactly. Right. Like the right, the goblins and the the toll bridge troll, right? Stuff like that. Right. What else? Pranav?
Um, maybe uh like different types of armor or weapons or stuff.
Right, sure. Sure. And also this so those are sort of all the things that are sort of like in the game. Also the game itself needs some entities also. So, you know, you need something to keep track of who the players are, something to keep track of what the score, you know, what your level is and stuff like that, right?
Mhm.
So that'll be and so we've sort of identified some of the entities. Now maybe like what about some state or behavior? Like if you had like a gold entity or you know like a prize kind of a thing, like what sort of state or behavior might be associated with that?
Like greed. Right.
Um, that's no, I wouldn't say greed. What sort of state would you have? So like, okay, you've picked a thing up. You've picked something up. So first of all, you might have. Whereas, let's say you picked up some gold. What do you need to know about that gold? Like, what differentiates it from some gold that you picked up in some other room?
Hmm?
So you're wandering around the game, and there's gold in the room, and you want to pick it up, right? So how much? How did what's different about that gold than from some other gold? What do you need to know about that gold besides the fact that there's just gold there?
It could be like different amounts of gold.
Right, exactly, right. So that would be sort of like one thing, one kind of state about gold objects would be, you know, how much gold is it? Um, I don't know that there's anything else. Probably just that. Uh, what sort of behavior would need to be associated with the gold? Maybe gold is sort of an inert kind of a thing, but right. Let's talk about the player. What kind of actions would need, or what kind of behavior would need to be associated with a player?
It can be like stamina, strength, and stuff like that.
And right, right. So well, those are sort of like state, right? So you know how much stamina they have, their current, that's sort of their current state, their score. But what kind of behaviors would they need? Like what kind of behavior between the gold and the person? What kind of behavior do you need to make something happen?
Do you mean by collecting them?
Yeah, right. Exactly. Right. You need to be able to like pick it up or something, right?
Mhm.
Yeah.
Mm-hmm.
Okay, good. So you get the idea. So that's one programming exercise, or one exercise I want you to do is just sort of like list out, and you know, until you get bored with it, right? Like don't knock yourself out. There's no right or wrong answer, whatever. But I want you to think about, oh, because this is the crucial step of programming is being able to sort of think about, to reason about your program and say, these are the major components of it, right? It's like, look, I have players and I have objects in the game and I have a score and I have, you know, the goblins that they're going to run into and trolls and evil people and good guys and other people. So these are the important things about, and that provides a framework. Once you have that identified, man, that's like putting up the frame of the house. You got the you know, you've seen a house go up, right? You got all the studs for the, you know, the walls and the roof, the rafters for the roof and so on. And then they start putting the plywood and everything on. And then they start filling on the inside. So getting the doing this step of identifying the entities, what's their state, what's the behavior, is like putting up the walls of the house. All right. So another thing too is I'm going to ask you to write a light switch program. So there's a light, and the light is either on or off. So that's like its state, right? And you need to be able to turn it on, turn it off, and so what we'll do is we'll have like a you know, like the echo program. You can just like type in like commands to the light. I want to be able to like type in a command to turn the light on, type in a command to turn the light off. And if you can do that program, that's like amazing. That's like that program sort of covers everything that we've talked about till now. So those are the three main things I think, unless there's something that I'm missing here, those are the three main things. I want you to go back and look at W3 Schools, sort of clear up a lot of the confusion and questions that you have, get your feet wet actually, like, because I just talked all day today. You guys didn't write one line of code, so I apologize for that. So going through W3 Schools, you'll be writing code, and then do that exercise with the entities, and then do a light switch program. And if you guys can do all that by next Wednesday, we'll be in really good shape.